Hello, everybody. It's Mrs. Pound, and we have been talking about sound and light and what sound is and what light is. And now we're going to move on into chapter 29 and talk about how sound and light behave when they cross into another medium or when they hit another surface. So we're going to be talking about reflection and refraction. And there's three things that can happen when a wave hits a boundary. And it can reflect, it can be absorbed, or it can transmit through. And so that's what we're going to be discussing. So our objectives for today's video is we're going to focus on reflection. So given the direction of light striking a reflective surface, predict the path of the reflected light, explain why the image formed by a mirror is virtual, describe the conditions for diffuse reflection, and give examples of way to control reflected sound. So let's first talk about reflection. What is it? Reflection is the bouncing back of a particle or wave that strikes the boundary between two media. A lot like this basketball. When the basketball player is dribbling the ball, he knows that if he bounces at a certain angle, it's going to bounce back at a different angle or whatever, especially if you've ever done a bounce pass, that follows the law of reflection. Now, when we're talking about reflection, the amount of light reflected from the surface of still water, if it shines on it perpendicularly, is about 2%. And the amount of light reflected from the surface of glass, if it shines on it perpendicularly, is about 4%. And this is much more noticeable if the background is a dark color like black, okay? Then you will notice these reflections more. And so some applications of this are when you look at the windows of a dark house at night, you see that reflection more. And also one-way mirrors apply this. So the law of reflection, I want you to go ahead and copy this diagram down in that first box on the front page, that big blank box. That's what goes in this diagram. And I'm going to be explaining it with the next slides. Okay, so in this diagram, the normal is a line perpendicular to the surface. So this is the normal. And we have actually talked about the normal when we've been talking about our forces and everything. So that is the normal, this line here. Angle of incidence is the angle made by the incident ray and the normal. So this is the incident ray. This is the angle of incidence here, because here is our normal and there is that incident ray. So that is the angle of incidence. There's also the angle of reflection. This is the angle made by the reflected ray and the normal. So this is our reflected ray. This is the angle of incidence here between the normal and that reflected ray. And the law of reflection states that the angle of incidence equals the angle of reflection, which is written in this box over here. But this angle equals this angle always. Now let's apply this law of reflection to mirrors. Now, when we look in a mirror, we're actually looking at what's called a virtual image. This is an image formed through reflection or refraction that can be seen by an observer but cannot be projected on a screen. So when a virtual image is created in a plane mirror, number one, the reflected rays diverge, they separate. Two, the image is located behind the mirror, and the image looks the same distance behind the mirror as you are in front of the mirror. And three, the image is upright. So taking a look at some ray diagrams, and go ahead and copy this in the space underneath where the heading is in your notes. So the ray diagram for a plane or a flat mirror, they call it a plane mirror because it's in one plane, it's flat. So if we look at this, mirror. Here is the man's foot, and it is sending a ray up to the mirror that is bouncing off the mirror to the man's eye. And so this would be the normal here, and this angle over here has to equal that angle over there. And so that is why it is drawn that way. And when the man looks in the mirror, his eyes follow this line straight, and the image for his foot appears behind the mirror the same distance as he is in front. And likewise, there's a ray that comes in here, bounces off the mirror from the top of his head, and goes to his eyes that follows the law of reflection. But his eye looks straight along this line to see the top of his head behind the mirror, the same distance on the other side. And so that's how a mirror works. And actually, only this amount of mirror is actually required to see his whole figure. And this is a virtual image because it is behind the mirror. Now, curved mirrors are a little different as far as the ray diagram. Go ahead and copy this ray diagram in the space provided. Each point on the mirror acts as a flat surface that reflects light according to the law of reflection. And so here, the ray comes in and straight on it just bounces back. Here, the ray comes in, bounces off. Now it's at an angle, so it bounces this way, following, and we have our normal here. And this ray comes in, bounces off, and we can see our normal that's perpendicular to the surface because it's curved. Now, this is an important spot, and definitely label this. This is called the focus, where all of those rays come together. And this would actually form a real image. It would be upside down, and we would be able to project this onto a screen. In fact, this is how your eyes work. There's also diffuse reflection. Diffuse reflection occurs when light is reflected in many directions from a rough surface. And in fact, we can read the print on the page of paper that you're looking at from any direction because the white part of the page reflects light in all directions from a rough surface. Go ahead and copy these two diagrams down. This is regular reflection, and we can see that law of reflection, everything is reflecting perfectly. This is your paper magnified. It has a rough surface, and so each spot does follow, in fact, the law of reflection, but notice it's angled differently. And so our normals are just all over the place. And so that is why you can actually read your paper from many different directions. So let's also talk about the reflection of sound. Not only does light reflect, sound reflects. And you've probably heard it reflect before. These reflections are called what happens when it reflects is there are reverberations. This is the persistence of a sound is in an echo due to multiple reflections. So if you were in this tunnel and you yelled out, hello, you would hear, hello, 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 okay? And those are reverberations. And the echo is the reflection of sound from a distant surface. So that hello talking back to you is a reflection of sound. So our objectives were given the direction of light striking a reflective surface, predict the path of the reflected light, and remember that angle of reflection, that law of reflection, the angle it comes in at is the angle it leaves at. Explain why the image formed by a mirror is virtual, because it's behind the mirror and it's right side up and those rays diverge. Describe the conditions for diffuse reflection. We have an uneven surface. And give examples of ways to control reflected sound. We didn't talk about that so much, but if you don't want echoes, you can have absorb absorptive materials in the area so that you don't get those reflections. That's why band rooms have sometimes padding on the wall to absorb those reflections, and you'll see that in auditoriums as well. So don't forget your 5 questions. And if you are still listening to this video, good job. I'm going to reward you for that. I want you to write a smiley face on the front of the paper next to your name.